Brain surface faults uh, has been a subject that been discussed for from different angles and for a long time. It mostly refers to the folding that began to shape between weeks 24 and 38 of gestation and continues with the brain development till the ages of 10 to 25. Uh, the brain reaches 90% of its adult size by the time a person is 6 or 7 years old. Although brain growing in size does not happen very much after, but folding continues later for small curvatures over the main folds, especially over the prefrontal cortex, where the brain develops cognitive and advanced emotional uh, tasks or behaviors. Cortex has a complicated folding pattern on surface, and it varies connectivity density between layers. The most significant the reason for this folding is the brain by growing has not enough space to accommodate those many neurons and find folding to accommodate them. A second explanation is convolution. Make neurons closer together to save energy during communications. While all these explanations provide a part of reasoning behind that, for the genetic part of increase in convolution in early life periods, but straining behavior of neural connectivity is behind of the later changes in convolution or very small folds by imposing of the stress forces from sensory channels and those imposed by body. These inputs also expand the small size curvatures all through the life, although they will degrade in old ages and due to the mental disorders. We call it all along life memory structure growth, which are semi-dependent on the from the size and genetic folds. There are subfolds and convolution on top of the main cortex surface folds. Genetic and molecular folds affect how sensory and internal inputs will be treated, and reversely, long-term memory, if it stabilized strongly in long periods, they may change protein molecules folding and become genetic in long term, at least between generations. According to the kinematics theory, increase in number of long-term memory motifs, their cumulative structure will change in small folding by time in locals because of the changes in connectivity configuration on increasing number of that. This happens in a self-regulating process. The brain is a complex system, especially during high frequency waves, both horizontally in waking and vertically in sleep. Connectivity configuration neural assembly uh, over outer cortex layers conduct short-term memory components where these components interact with connectivity configuration over the inner layers of the assembly, and this connectivity configuration in inner cortex layers are called the long-term memory motifs, or stream bit for short-term memory and working memories. Each cortex area will expand in fractal shape for repeated short-term memory components. When this repeating happens in different experiences and experiences of inputs. In other side, short-term memory currents during waking will follow stress energy attractor streamlines to approach strain balance states. These interactions will cause straining and elongation of the cortex layers, although not significant in short terms. The cortex small size force will expand over the main genetic force, where the main cortex folds are made. Interaction of the long-term memory with the short-term and working memories will provide meaningfulness to their emergence by providing similar applicable cases in past. I want to just highlight this point, that this interaction has got the physical effect of the increase on convolutions and curvatures of the cortex layers, as well as has got some functional aspect, which is convolution of the brain surface is generally a stress-straining effect, initially under genetic guidelines and later under environment and related forces imposed through sensory or body connections. The initial genetic development of brain happens during the third month of the pregnancy, a period in which the brain undergoes considerable growth. It continues after birth with significant slowdowns in 2 to 3, in 6, in about 14 and 24 years old milestones. Those the cortex general basic format for functioning and its curvature growth during early life are linked through the organization of the neural connectivity hardware that initially have been fixed. However, it continues for changes under environment experiences later in parallel. shifting more to changes on their body and environment effects of their childhood ages. Effects on their environments are through sensory and hormones, uh, and the, the media for these changes in structuring is by long-term memory that are consolidated uh, for the experiences. Let's see how long-term memories will be consolidated and change uh, slightly convolutions of the cortex surface over the basic convolutions that genetically had happened before. Strain residual packages will mostly trap and confine where there is a mix of vertical and horizontal connectivity within each neural assembly. There are mix of granular and pyramidal neurons in uh, layer 3 and layer 5 of cortex. Residual strain packages remains from short-term memory current uh, over their long-term memory stream bits, uh, and this the residuals remain on uh, layer 3 for upper resistance, and in L5, level 5, for uh, long-term memory resistance. Residual strain package remain because although long-term memory structure conducts short-term memory currents, but both sides resist to change under each other. Long-term memory resists to change somehow under short-term, and short-term tends to form freely uh, to spend or consume least energy. Those both L3 and L5 retain some strain residuals to be released after. The above residual strain packages depend on two aspects. Uh, One, the strain carrier wave follows the neural assembly uh, which go through that. It is zero if such the uh, stream flow is its linear, is within the linear viscoelastic property of the tissues, but will be non-linear if the strain wave would be in high kinematics, like the focus, the waking uh, uh, in daily life. Uh, the other factor is vertical oscillations, and these vertical oscillations indicate activation of the neural assemblies because of the inputs, and in these inputs mostly are introduced through layer 4. The combining neural assembly, the combining forces from the strain carrier waves, as well as from the long-term stream bed in the inner layers, and from inputs from layer 4, uh, will cause that the whole neural assembly to twist around a straining axis, which this straining axis, of course, is variable, is not fixed, depending on the all mentioned factors. And now let's see in which direction strain energy follows within each neural assembly. A granular type of the neurons, uh, mostly they connect neighborhood neural assemblies together. In other side, uh, pyramidal neurons connect the, the assemblies in the different layers vertically together. Although neurotypes are mixed in different layers, but some layers significantly are rich in one type of the neuron than the other. Type of the most populated neurons in layer 1 is granular. It connects thalamus or all inputs as well as outputs to the cortex, as well as between the different areas of the cortex. Layer 2 has got mostly a general type of the neurons, and these are external ones which connect the different neural assemblies together horizontally. Layer 3 is enriched in pyramidal and mostly connect between layers the networks. And layer 4 is a mixed layer, but somehow enriched in granular mode, and it receives it is a matrix of the cortical and thalamus cortical, means that between the neural assemblies as well as between the limbic system and the cortex. So mostly it connects, because it is a mixed type of the layer. It holds the residual strains. Layer 5 is enriched on pyramid type and mostly connect between layers. And layer 6 is more containing granular than pyramids, and they just form very rigid connections to encode information, and this is the layer that consolidate the long-term memories mostly. It is not only difference in neural type, density, and size between layers. There is also differences in different cortex areas. Type of the connectivity in each neural assembly determines the type of the long-term memory motif or memory unit that will consolidate by time in that location. In other words, each cortex area has different specialty. Again, in other words, it means the memory motifs in each location have similarity in connectivity configuration topology, and they symbolize each other in vertical direction, but not in the horizontal. Uh, Cortex surface curvatures change from area to other area, and connectivity also distribute differently in different areas as well as layers. This difference is very considerable in the inner layers, which they contain the long-term memories, but are more flexible in the outer layers. And the other point is regarding the thickness of the cortex layers. Thickness of the cortex layers also changes from region to region, and it affects very much the type of the long-term memory which consolidate on those areas and type of the specialty they have. We explained the long-term memory structure, the how it forms a short-term memory current, while the short-term memory itself tends to be free from the long-term, so that to follow the pathway that consumes least energy. As a result, components of the short-term memory will leave strain packages in neural assemblies along the pathway of long-term memory motifs, both in their third and fifth layers. In this slide, the left graph shows a straining of a pathway that short-term memory creates from its initiation to termination, accumulating there. The right graph indicates the lifetime of a short-term memory. How long does it last? The maximum strain magnitude reflects the strain residual accumulation in terms of the psychology. It is referred as emotion. This strain residual rises during short-term memory occurrence and will discharge into the limbic system for the amount that it is over capacity of the strain absorption of the relevant neural assemblies. Each of these straining steps in the left or right graphs indicate a straining of a neural assembly that matches the component of the short-term memory. with similar line-term motif uh, based on the connectivity configuration. Just as a note, short-term memory, we refer that, for example, there is the object, there is verb, there is adverb, there is adjective to define the noun and as well as the subject. So these are general components of a short-term memory. How connectivity configuration appears as an information package and a train of them in a pathway generate a concept or an integrated information. We call this phenomena as encoding and recalling processes of a unit of information package. A unit of information will be encoded by connectivity configuration that has happened strong with strong plasticity between groups of neurons in inner layer of a neural assembly. Recalling of that during brain activity will happen when a resonation occurs between oscillation of the assembly with there's a strain carrier wave that cycles through that. Recycling of information unit happens when recalling of the information unit happens when an information package travels from inner layer to outer layer, where it is the opposite to the encoding direction, which in that case the strain package had imposed from outer layer to inner to encode that information. To have the information package recalled, a resonation again should happen between oscillation of the assembly with the strain carrier wave cycling. That will generate the outward strain package follow to pop up in the strain carrier wave. The activation of the assembly either to encode or decode information happens by an absorption-desorption of a related strain package that will appear and disappear during the above mentioned resonation. Remarks in this slide is reviewing the remarks already done in the previous presentation slides, but it is needed actually to follow the rest of the subject in this presentation. Rigid in the inner cortex layers we have a rigid connectivity configuration, and in outer layers the connectivity is more flexible and when it is exposed to different strain carrier waves will take a different configuration. Connectivity configuration as already told varies depending on the type of the strain carrier waves, especially its kinetics. which goes through the neural assemblies along the pathway. Those they may recall uh, different motifs or different memory units in different situations. Uh, for example, in waking, maybe uh, the, the, the thoughts are combined of the some sensory objects or some uh, concepts, but for the same mental events in dreaming, uh, when the imposed strain packages are relieving, they may recall different motifs, although they are different, but mostly they are symbols of each other. And this is because in each location of the cortex we have a fractal structure of the memory units. As already told, depending on the type of the cycling strain carrier wave, different memory units will be decoded and recalled. Uh, this situation also could happen during the different uh, waking mind states. We know that the sleep consists of about 5 cycles, and in each cycle the wave frequency drops to deeper stage of sleep and rises again to about waking state, in which it is called REM stage. In most deep stages of sleep, most small memory units will consolidate, and as much as wave frequency increases, the smaller units will integrate in a bigger unit. This will improve in or develop in sleep cycles, along the sleep cycles, and probably a full memory will be saved during all sleep stages. During the intermediate sleep stage, which is called the non-REM 2 stage, the the uh, the segment of the memory which are consolidated are fragmental. There are the first pieces of the memory that also has attached consciousness to it. In lower frequency, there is no consciousness, and we are not aware what is going on. But from non-REM 2, the dreaming appears in fragment and the short fragments, and increasing when it goes to REM stage, especially from the REM in the first cycle of the sleep to the REM before morning wake up. In Dreamium 11-0, which was the introduction to this presentation. We describe strain balance around a neural assembly. Here in this presentation, we are going to make a strain balance for a full one brain activity around the related pathways or the cortex. However, to develop this study, we need again to repeat the main topics for the strain balance around each neural assembly to and develop this study unit to the more integrative scale. The first in making a strain balance along brain activity during the day and its continuation to be saved in a sleep time or relaxing time is not such straight. We should remind that conflicts and strain rising that happens between the short-term memory and related long-term stream bit always does not result in giving birth to a new memory unit. It may reinforce or lose existing connectivity configuration that base the existing memory unit, or even may erase that. A long period of dreaming periods is about this kind of challenges, and especially the long-term memory structure will be modify itself by erasing a lot of unused or weak long-term memories. Here it is good to look to the subject of the long-term memory motif consolidation from a physical aspect. When and where connectivity configuration will reconfigure and consolidate, giving birth to a new memory motif. Different parameters are involved. Please consider all figures are given here are very primary and just to have an idea. A strain carrier wave should impose a potential stress force to the neural assembly in its non-linear range of viscoelasticity, and that force should be at least 10 Pascal or more to create and stabilize a strain residual package in third layer of the assembly. As pressure means that the vertical stress force imposed by the strain carrier wave increases by decreasing in kinematics of that wave. The strain residual package will be pushed on to layer 5. Whenever the strain goes beyond 0.01 to 0.05% of a strain in any angle, it will be the yield point for the connectivity in the layer 6 to reconfigure uh, reconfigure and consolidate a new connectivity configuration that encodes new information. In previous slides, we just touched the size of the long-term memory motifs that consolidate in different brainwaves. Under delta brainwave, which happens in the deep sleep, smallest long-term memory motif size will form. Under theta brain waves, which is still a deep sleep stage, but just going to emerge consciousness, mental streamlines between motifs in areas and regions in one cycle of the brainwave around the cortex will form. This happens normally in non-REM 2 under alpha brainwave, which is REM stage of sleep. Long streamlines in a pathway connect the fragmental segments in stream bundles, and it happens during several cycling of the brain wave around the cortex. There is 2 points to mention. First, the definition of the brainwave. The brainwave normally refers to the neural oscillation in normal definition. However, here in brain activity kinematics theory, an effective brainwave refers to the time that this oscillation and strain wave circulation rate, they will resonate or lock together, and they actually generate a power either to recall in the high frequency waves or to encode in low frequency waves a memory unit or an information package. So the definition is slightly different, at least if we call it an effective brainwave. An effective brainwave is the one that will emerge short-term memory or working memory through the or among the strain carrier waves. Again, the brain functioning differs under different brain waves. In lower frequency and higher power full brain waves, memory consolidation happens. In opposite, in high frequency and low power brain waves, recalling or conscious state of mind will occur. In medium brain waves frequencies, both recall and memory building continuing in parallel, as it happens in dreaming stages of And when we refer to cortex connections, cortex has horizontally long connection between areas and regions are referred as tracks, and short connection which locally connect neurons together. Long-term memory structures, uh, they have sites all over association areas, and tracks archive different uh, type of the information and subjects. In the same time, in each location, different memory motifs vertically have relative similarity in connectivity, configuration, morphology, and they symbolize each other. But it is not the same for the assemblies in different areas. Different memory motif will be activated in each location depending on the stress carrier wave frequency power. When they resonate with the neural assembly oscillation and synchronize recalling information that joined along the pathway, they will form or merge a short-term or working memory. This pathway actually is attracted to the streamlines that form an attractor. That is because they are tending to arrive in a strain balance in a brain activity scale. Just summarizing all the previous slides, the part of the cortex folds actually which are connected to which are about very small curvatures over the basic ones which are created in the early life. They are because of the strain residuals which temporarily happens in different locations, as well as long-term strains which are consolidate the connectivity configuration in certain way or morphology. In kinematics theory, it is assumed that recall of the memory unit happens by related strain package medium, but the cumulative strain residuals attached to a complete activity will be referred as emotion arousal. Also in this theory, positive and negative emotions are referred to the type of the straining over the connectivities, either in concave or concave shapes. Here I would like to just give a tip regarding thermodynamic law, folding in the brain tissues from smallest sizes uh, in connections to largest connectivity configurations. They follow the minimal space-time connections to consume the least free energy possible in time and distance. This is because they approach as a natural tendency to come in a strain balance. This happens also in more smaller size of the protein molecules, which they form the brain tissues. Protein foldings also follow the same rule of the minimal space-time connections, and they consolidate in the same way as we can see the basic brain force on the cortex surface during the early life as well. Follow the same rule. They all follow the same thermodynamic regulation. As already explained, short-term memory components will be stored relatively and as much as possible over the long-term motifs of similar morphology, connectivity morphology. The interaction will be accompanied with the merge of a strain package, depending how much they are similar, and it happens in low frequency for consolidation and high frequency for recall. Recalling and consolidation happens in fraction of the seconds for small information packages to the seconds and more, sometimes minutes, for complete information that a short-term memory conveys. Next video, strain balance will be extended not only for one brain activity, but for the all brain activities happens during day and related consolidating time in sleep time. Please do not forget to send your comments and questions to most.dini@gmail.com, and thank you for watching.